Yeah, that's good. There was a gentleman I was talking to. Yeah, recording.
Well, good evening, everyone. Let's go ahead and get started. It's 10 seconds before 5:15. First of all, next week, we're well past the halfway point. I think we've only got about 4 speakers left this semester, so please keep coming if you can. We've got a fascinating speaker next week, me. I'm basically going to speak on energy in China and energy in India. I gave a similar talk about 5 years ago at the Symposium. This is significantly updated based on recent trips to China and some work I've done on India. We're basically going to talk about energy infrastructure, energy portfolio of both the countries, how they're changing, why they're changing, and what it means for us, what 3 billion people are going to be doing for the next couple of decades, and how that's going to influence us. And believe me, we're not driving the train. The 3 billion people are. So that'll be next week. Hopefully if that interests you, come on out and we'll have a discussion and throw some new information at you. Tonight we've got a real treat. We've got Professor Dr. Todd Davidson. Todd works with us at the Energy Institute and at the Weber Energy Group. Todd did his bachelor's degree in engineering science just down the street at Trinity.
That's right.
Sweet.
Yeah.
Nice little school down there, very good school. He went and worked in industry for a while, notably at Raytheon Missile Systems in Tucson, someplace very near and dear to my heart, and even led a company for a while. I didn't realize that. Why didn't you tell me that? I'm all over supercapacitors, so it'd be interesting to hear more about that. And then he came back here to UT to work on his master's and his PhD, finished up a couple of years ago, so now he's part of our group and, like I said, the Weber Energy Group. Tonight he's going to talk about a very timely, a very compelling topic. My way of phrasing it is to own or to Uber. That's kind of a bastardization of this very technical, quantifying the economic and energetic. Yeah, he really wants to be an academic here. Very good topic. But it's compelling. Huge capital cost owning a car. Very underutilized capital once you own one, sits idle most of the time. So this is becoming a question that's becoming more and more compelling as time goes on, and it's a question a lot of us are going to be asking ourselves in the very near future. So without further ado, Todd, I'll give it to you.
Thanks,
Fred. Look forward to hearing it.
So that was a great introduction. I appreciate that, Fred. That lays the groundwork well. We'll be talking basically about whether or not you should own a personal vehicle or whether or not you should start using mobility services. And when I say mobility services, I'm speaking about Uber or Lyft or any of the other service providers that are sort of multiplying almost daily in some cases. And when I talk about using mobility services, I really mean completely getting rid of your car. So when we start talking about some of the economic trade-offs, I mean entirely using mobility services for every single trip that you make to the grocery store, et cetera. So this work was funded by the Department of Energy, Oak Ridge National Labs, and as we've described, right, it was essentially to build this framework for quantifying the trade-offs between these two choices. And I speak of this in terms of a binary choice between mobility services or personal car ownership, but of course it's much more complicated than that. We have public transportation, we have cycling, we have walking, we have a variety of options that I'm not necessarily reflecting here. I will touch upon those, but for the sake of simplicity, we're keeping this to a sort of a binary discussion between these two choices. To give you kind of the punchline, at least one of the conclusions, is that our work would show that mobility services are cheaper for roughly 30% of the population in the United States in terms of drivers. That is a significant portion of the population, in my opinion. Now, granted, the real answer is it's complicated. And so we're going to talk about some of those complicated aspects. We're going to talk about some of maybe the economic behavioral aspects as to why or why not people would do this. And then eventually we'll talk about some of the energy implications more broadly for the United States, and then subsequently those will travel abroad or maybe even grow faster abroad, but we're not going to touch into stuff that's not domestic. So I want to lay the groundwork at first in terms of talking about just how Americans move around the country, at least in terms of how we get to work. This is a map which I found to be very useful data, which I'm about to show you from Nathan Yu at Flowing Data. And what we're going to see is every county of the United States light up with a specific color based upon the mode of transportation that you use to get to work every single day. And so now what I'm showing is non-motor vehicles, so your selection of walking, bicycling, or using, or just working from home. What we see for the most part across the country when we just limit it to non-motor vehicles, right, we can see kind of the scatter pattern of walking and working from home. Rarely do we see that biking is actually the primary mode of operation in this sort of down-selected set of data. If we were looking at the Netherlands, it would look very different. Cultures that have a very large penetration of cycling, maybe we have something to learn from, frankly. Now we're looking at motor vehicles, but we're not talking yet about driving alone. So purple is carpooling to work. Public transportation is kind of a blue, which you can see a little bit up in Manhattan. And then taxi or other is also shown, but for the most part, it's carpooling across the country. And then the real kicker is driving alone, right? This is what we do in the United States. We drive alone every single day to work, back and forth from our homes or our apartments or wherever we live, except for maybe Telluride, Colorado, and Manhattan. Those are a few outliers, and then of course up here in Alaska we have very limited data sets, so I'm not really sure I believe the amount of walking that's going on in the north slope of Alaska seems unlikely. So the reason I bring this up is because I believe that any solution for transportation must involve the automobile at this point. We are so committed to the automobile in terms of our established infrastructure that it is, to me, an inevitability that we will continue driving one way or another and utilizing our roads. Now, can we be more efficient with that, with public transportation and cycling and walking, creating better urban centers? Absolutely. That needs to be part of the conversation, but I would suggest that if we don't include and improve our automobiles, we will be continually facing the challenges that we already face in terms of our transportation behavior. So let's quickly talk about kind of a glimpse at some of this multifaceted problem. So roughly 33,000 Americans die every year in car crashes. We use about 140 billion gallons of gasoline were consumed in 2014. It accounts to roughly $550 billion were spent on new cars in 2014. It's not necessarily a bad thing, right? Spending money to purchase cars is economic activity, but is there a way that we can do it more efficiently, that we have more disposable income for additional activity in the economy? And then last, the average American spends roughly 42 hours per year in traffic. So let's do some quick math, at least make the math relatively simple. Imagine that you did that for 50 years, which might be on the top end, but still just do simple math. That's 2,000 hours that people are sitting in traffic on average. 2,000 hours equates to roughly the equivalent of an entire year of productive work, right? 40 hours per week, 50 weeks per year. That is a significant drain on our economic productivity in the United States and around the world. So getting these numbers down, to me, is not just a matter of, I guess, making ourselves happier, but it's also a matter of actually making our economy more efficient, because that's a non-trivial improvement in what we might be able to do. This is a traffic jam outside of Beijing, something that I would say most people would not want to be involved in. Here's another one. It's pretty amazing to actually watch some human behavior when traffic lights fail. Here's another one, right? My point in bringing some of these up is that automated vehicles and kind of the push towards electrification in a variety of ways, shared autonomous electric vehicles, so SAEVs, as is often used, will they begin to improve some of these situations? Probably, but maybe not. It'll be interesting to see how some of this reacts. Most of those pictures were overseas, but before we think that we're better than some of those drastic scenarios, we have really bad traffic in many parts of the United States. We face bad traffic in Austin, but actually a colleague who now works with us at the Energy Institute just came from outside of Delhi, and he was telling me, you've never seen traffic. And I believe him, because actually I've been to Delhi. He was in fact talking, just as a quick side note, he was talking about driving to the airport. It was like a 3-hour drive, and he got to the airport and he couldn't get out of his car. Why could he not get out of his car? The cars were packed so tight you couldn't open the doors. And so he unfortunately missed his plane after the 3-hour commute, and then you couldn't even get out of the car because you could imagine all of these cars next to one another. So it'll be interesting to see how autonomous vehicles and such actually improve, or hopefully improve, some of the situations abroad, which will potentially be a real challenge, but we'll see. It'll be interesting. Here is, I think, a great article from Logan Green, CEO of Lyft, claiming or stating that the current model has got to be the worst way of organizing people. He published this in MIT Tech Review. not too long ago, worth looking at. And so, the question then is, there must be a better way forward. Many are suggesting this, as we've already implied, right, that this is the better solution to move us forward, is using mobility services like Uber and Lyft, and then combining that with Google and Waymo and the rest of the world that's developing autonomous vehicles. And many would think that this was, these are brand new ideas, but actually pretty interesting kind of going back and looking at some of the history. From 1976, a scholar in transportation argued that the most efficient public transportation system might be an army of less regulated taxis. This was published in MIT Technology Review, and I quote Martin Wohl, "Private automobiles and taxicabs quite simply can provide attractive and convenient door-to-door service at a price that most travelers are willing and able to pay." I think it was pretty prescient looking forward as to what maybe a private fleet of vehicles might be able to achieve in terms of our transportation behavior around cities. But of course, Uber and Lyft have to compete against car ownership, which is what we're going to be talking about. And first I would try to bring up, do you realize the total cost of owning a car? Because it is immense. Total costs add up to roughly $16,000 to $17,000 a year if you begin to start taking everything into account. Per year, people are spending over $10,000 to operate a conventional vehicle. So your ownership cost might be on the order of $5,700. This is assuming an average price for a vehicle on the order of, say, $33,000. Maintenance around $1,200, assuming 8 cents per mile of maintenance, which is quite reasonable looking at some of the literature. Fuel around $1,500, that's assuming $2.30 gas. Parking, this might be a little bit on the high end, but it is very real in some cities. About $6 a day, that adds up to $1,400 a year. In some places, parking is quote unquote free. We treat it as a public good. I would challenge that notion. We spend a significant, and in fact, quite staggering amount of money in maintaining free parking. And so I would say that if we actually began pricing it at what it's really costing us, we begin understanding more so what our transportation system might really be causing. Lost productivity. This is the big question that we'll be talking about a lot today. Pricing this in terms of an average based on household income of $26 an hour at roughly $6,700 a year, adding up to roughly $16,000. Now, of course, it's subjective as to whether or not that's lost productivity. If you listen to a podcast or radio or you learn Spanish or whatever it might be while you're driving in your car, that's not necessarily lost productivity. But in many cases it is. Sitting behind a steering wheel, many people would prefer to be doing something else. Here's some other things that often are not necessarily acknowledged in terms of our transportation behavior. Many people are paying $10,000 to give a car a house within their own house. And what do I mean? I mean that garage that's on the right-hand side there. So many people are paying the property taxes, the cost to maintain it. Some people are even air conditioning their garages. Garages, of course, serve multiple purposes. They're valuable for a variety of reasons in terms of storage. But it will be interesting to watch how does even residential construction behavior change over the course of the next 40 to 50 years if shared autonomous electric vehicles really take off. If people are no longer really owning a car, are we converting all of these into in-law suites? Are we renting them out on Airbnb? Are we almost doing away with them entirely and just having more lawn space? It'll be interesting to see sort of these cascading impacts. I'd be happy to talk a lot about the cascading impacts, but it's almost an endless rabbit hole. So moving forward, I say again, into a man cave, or I heard one recently, now I forget what it was. It was something great for women. It was like a women, I forget what it was, but it was a she den. Yeah, well, I think it was literally that. So the hypothesis of the work, right, was that if we accounted for all the hidden costs of ownership, and mobility services would appear economical for a significant portion of the population, which we already suggested, right, something on the order of 30%. And so our goal was to build this model that accounts for the known benefits and some of the unforeseen, I guess, expenses of our transportation choices. I won't go through all of these, but here are some of the variables that went into this system. In terms of the global inputs, kind of see average annual miles driven, time, trips, number of trips taken, critically the time worth, which we'll talk more about. The mobility services expenses, I think the one that I want you to pay most attention to, because it'll be relevant to some of the things we say, is distance variable costs, so like the dollar per mile that you are charged. Car ownership expenses, we have upfront cost, just the price of the car, and then we have things like the direct cost of owning it, which I would say is like insurance and fuel. And then there's indirect costs like the garage property tax, things of that sort. In reality, garage property tax is a very small portion of the economic equation, but it's still, I think, interesting to bring up just to have people acknowledge some of the hidden costs that are not normally considered. Bunch of tables now with actually the jargon, which we don't need to get into. The cost to hire is a pretty basic statement, right? Is that the equation all comes down to, is the cost of hiring somebody to drive you around less than the cost of owning? And if that holds true, then we should always hire a mobility service company. A little more detail, we don't need to get into all of it, but the thing that I want to point out again is that the cost to hire is the sum of a variety of expenses, and then in particular the cost of the time associated with you hiring that vehicle. So for instance, how long does it take, are you sitting on or waiting at the curb for somebody to show up? And arguably or questionably, are you using that time productively, or is it a waste of time? Would you rather be walking home? And then the cost of ownership, another summation of a bunch of expenses, and then the cost of owning a vehicle. So in that case, it's like the time or the cost of time for owning your vehicle. In that case, it's like the time that you're spending sitting behind a wheel. And is that time being used productively? You have to counterbalance all of these questions. So the most important question, what is the value of your time? As I noted earlier, we spend a lot of time driving our vehicles. The average commute time one way is roughly 25 minutes. Of course, I bring up this map because I think it's really critical to realize that that varies dramatically depending upon where you live. Right? Some urban centers are very different than some rural regions of the country. And so one answer will not fit all for this work, and I'll get into how we solve that question in terms of not being able to give a single answer for everybody. On kind of since I did my PhD in mechanical engineering and did a bunch of thermodynamics at one point in my life, I actually wanted to circle this back to a little bit of that to give an inkling as to the idea of exergy. And the idea of exergy is the quality of energy, right? So you might have a certain amount of energy. In two cases, you might have the exact same amount of energy. But in one case versus the other, the quality of that energy is much, much higher. Like you might be able to extract much more useful work from one of those cases in terms of the amount of energy that's available. And this idea, I think, actually lends itself well to this analysis because it gets into what is the quality of your time. And so as a quick example, imagine that you have some 3-hour block in your day. Those are segmented into 20-minute sections. And imagine in this case one that at the end of every 20-minute section, you get 2 minutes off. That's not very valuable time, right? In case two, you have 6 minutes off every 60 minutes. Okay, with 6 minutes off, maybe you can potentially start doing something a little bit more. In case three, we now begin to see that we have 18 minutes off. Now, in each of these cases, we have the exact same amount of time with the exact same amount of time off, and yet case three would arguably be much higher quality time that you've recovered. And that gets into this idea of exergy of time, right? That you don't just have exergy of energy, but you have exergy of time that you're trying to recover, and arguably you're trying to recover that when you're using or choosing whether or not you use something like mobility services. Are you recovering valuable time by using something like mobility services? Because if you're only recovering, say, a 2-minute section of time, that's not going to be very valuable. You're not going to be able to get much done. You might not even be able to take a nap, right? Which is another thing that I forgot to mention. Is that when I talk about recovering time in a vehicle, I'm not just talking about doing work, but I'm also talking about maybe you just need a break, and you might actually put a dollar value on that. You might want to read a book. You might want to check email. You might want to do a variety of things, all of which could actually be considered valuable that you would put a dollar value on. But it's unclear that until you basically accumulate a sufficient portion of that time, whether or not it's actually worth it for you to pay for it. So, kind of reiterated there, right? The value of your time depends on the quality of the time that you extract. So, our first generation model, you don't need to necessarily pay attention to all the numbers, but we're going to start talking about that comparison of the cost to hire versus cost to own. The biggest thing, or at the most simple level, what we're doing, right, is adding up everything in all those blue numbers, which is the cost to use mobility services over a varying number of years. And then we do the same thing for an ownership model, and we add up all those costs. And then we take the ownership number and we subtract it from the blue number, and if it's negative, it basically means that it was more expensive to use mobility services, which means we should own a car. And that's for a specific scenario that's shown in the top right, time worth $25 an hour, car price $30,000, roughly the average consumer or commuter rather in the United States. And if we plot this, we see sort of an ever-increasing or decreasing number, more and more negative, which suggests that you should more increasingly own a car if you own that car for a longer and longer period of time. So own a car down. Above the x-axis would be hire a vehicle. Now, instead of paying attention to numbers, let's just pay attention to colors because it's a lot easier, right? So if it's red, it means you should own a car. And looking at this now, this is the exact same scenario. If it's red, it means own a car. Now let's change one of the variables, which we just changed the daily miles on the top right to 27 miles per day rather than 35 miles. And we start seeing a little bit of blue show up here on the very left, which means that if you only own your car for, say, 4 years, you might be better off using mobility services, even in this scenario. And the reason why is because you paid a bunch of money up front for that car, you're paying financing, et cetera. And it might have been better for you to just use mobility services. But if you own that car for a long period of time, it'll eventually become better and better for you to own that vehicle. Now, if we increase the car price to $50,000, shown in the top right, we now see that mobility services might actually be preferable all the way up to year 7. The average length of car ownership in the United States is roughly 7 years, 6.5 to 7 years. I was actually amazed by that number. I guess in part it's because I still own a truck that I bought in high school. Now, granted, I now own another car, but I still own that vehicle, and if I ever own cars, I will probably drive them for as long as I possibly can because they're already depreciated assets, and yet I can still extract useful work from them. And so it'll be interesting to see how that plays out, but the average consumer in the United States owns a vehicle for roughly 7 years before they're transitioning to another car. So in this case, we do see some mobility services show up. What really starts changing the needle is if we increase the time worth up to $55 an hour, which is a lot of money. But for the sake of showing an example, I wanted to bring this up. Now we're seeing basically all blue. You should hire a T&C for the rest of your life, essentially. But the question, this gets back to the productivity question. All these numbers up until now was assuming that you were recapturing 100% of the time as productive value at that specific dollar per hour that we were showing. If we change that to, say, 75%, you can see how much it changes, right? And so I think it's impossible that people will extract 100% of their time, but can they extract 75% of the time? Maybe. It's probably more likely that maybe they extract 50%, but they're definitely going to extract something, and that's some of these subjective questions that we'll talk about a little bit. Let's consider some more scenarios. This is outputs from, I guess, our second generation and eventually our third generation model. What we're seeing here, just to orient you before I show you data, the y-axis we have value of time, x-axis we have car price. What's going to happen, you might imagine this, is that if you purchase a really cheap vehicle and you value your time at a really low dollar value, it'd be much better for you to own a car because you're not burning cash basically by sitting behind a wheel. If you're purchasing a very expensive car or you perceive your time value to be very high, then it's probably better off for you to hire a T&C. So this is one of the basic scenarios where annual miles driven are roughly 10,000, dollar per mile is $1.50 per mile. There's a lot of debate about what the right number is on a dollar per mile basis, but $1.50 is not that far off in terms of what the market currently is. In Austin, it might be closer to $1.30 or even lower, but there's also an interesting discussion regarding this, how much essentially private equity and venture capital are subsidizing the prices that all of Lyft and Uber are being able to essentially offer customers in order to try to grab up market share. But that's a whole nother longer discussion, if you will. So this is even more So I'm realizing that it's probably kind of jarring, but again, orient you a little bit. It's the exact same method for displaying data, but now we've gone to sort of a three or arguably four-dimensional space where we have annual miles driven as each of the rows, and in terms of the columns, we have the cost per mile that the mobility services are charging. And then we see, as you might suspect, if you drive very few miles and the cost to hire TNC is very low, it's very blue. And very blue means you should hire mobility services. On the contrary, on the bottom right, it basically means you should own a car. So if you're driving a lot of miles every year, and if you have a very high local cost of mobility services, then you should definitely own a car. The average consumer is somewhere in here. We see a lot of red, but we also see a lot of blue. Now the problem with this, which I'm going to get into here in just a moment, is that I think these figures are kind of distorting visually what the real answer is. So we're going to try to adjust for some of that. And so to eventually get to that adjustment, let's first talk about this, which is the wage distribution, a cumulative distribution function of wages in the United States based upon reported wages to the Social Security Administration. We see that 50% of the United States on a per person basis is reporting wages of roughly $14 per hour. And so I'm going to use this number because I think it's a pretty critical number to recognize that people are reporting wages that are $14 an hour, whereas actually often we hear numbers more on the order of $26, but that's often like household wages, so there's some complexity in terms of how you interpret this data on a per person basis and what per person income really is. The median, that is, not the average, the median. And so the median wage being $14 an hour according to the Social Security Administration, and the median car price at around $29,000, we see this intersection of these two median data sets that is very red. We still see a lot of blue at the top left, but it kind of suggests that actually the majority of people are down here. And so visually we're kind of being distorted because we see a lot of blue. So we're going to try to adjust for that here in just a moment. One other quick comment is that even though the Social Security Administration might be reporting wages of $14 an hour, I would actually suggest there's an argument to be made that maybe we should just set it around like $20 an hour, because there's a lot of people in the country that might be, say, a stay-at-home mom or stay-at-home dad who are not necessarily reporting wages, but clearly have a value of their time. And so it's unclear what exactly it should be, but just for the sake of an example, let's say it's $20 an hour, and instead we use the average car price. It shifts it up and to the right, but not that far, right? We're still really pretty deep in the red, which is an important takeaway. So some of the distributions that are critical to this analysis, we have probability distribution on the left in terms of driving distance, so miles driven per day, and then this is driving duration per day. And then turning those into cumulative distribution functions, so the same function as previous, but then just adding them up as they accumulate. We can see where the median is for the United States in both cases. And so in terms of miles driven, we're at roughly 35 miles driven per day, and in terms of minutes, we're at roughly 75 minutes per day for the median commuting behavior. For a distribution function of car price, this took a lot of genius work by a colleague, Gordon Tsai, who's sitting in the audience, helping to develop this distribution of car prices that are purchased in the United States. And we see, well, I just changed it, but we see this is the same chart. We see this is where we get our data in terms of the median and the average car purchase prices. So these two data sets, I'm going to use them to change those heat maps that we just saw. This green distribution of car price is going to be used for the x-axis, and the wage distribution is going to be used for the y-axis. And so what do I mean by that? So this was one of the heat maps that we just saw, right? We have a linear distribution of car prices on the x-axis and a linear distribution on the y-axis. But this is not linear, and nor is this linear. So let's try to change it visually so that it more accurately represents what's going on. So again, just kind of repeating what I just said, because it gets kind of confusing. This is linear, but this is not linear in terms of the distribution of where cars are purchased. So this is what we did. We changed this axis to represent that weighting. We changed this axis to represent the weighting of what's reported to the Social Security Administration. And I would argue this gives us much better appreciation visually as to what is actually happening in the United States in terms of whether or not you should own a car or use mobility services. And you can see it's now much more red. All that blue got pushed into the far corners and the far right hand, or the far right-hand side and the top. Now, this doesn't mean that you definitely want to own a car, but it does mean that a lot of people in the United States likely should own a car. And this is for a specific scenario where you have $1.50 per mile and 10,000 miles driven annually. Let's change that now to, instead of being $1.50 per mile, I've now changed it in the top left to being $1 per mile. And now we see that the median individual in the United States is pretty smack dab in kind of this gray zone of whether or not they should own a car or use mobility services. And this is where you begin to get a really compelling scenario that mobility services might really eat into personal car ownership if they can push down the price on a per mile basis. And so we're looking at, basically we're taking all of these distribution functions and we're using Monte Carlo method to then try to estimate what some of those consumer behaviors might be. And we're doing something that is, or I need to acknowledge something that is really critical, is that we are assuming that people are economically rational is not necessarily the right phrasing, but that they are trying to choose options that are more affordable than others. And there are options that are even more affordable than this, like public transportation. But as an example, right, there's a lot of people that choose to not use public transportation. So almost by definition, the case that I'm using has some holes in it. And I'm more than willing to acknowledge that. But for the sake of at least trying to get us to a rough estimate as to what we might be looking at, a notional result, just to again orient you, we're looking at a distribution function based on, or a notional distribution of that Monte Carlo simulation, and this is more the real data. So this is real data of one of the many simulations that we ran, where we see anything to the right is ride and anything to the left is drive or own your own personal car. It's important to look at the shape of this curve, and this curve is very spiky, which means that there's a lot of people right on the margin. So from one standpoint, you could argue that because of basically cultural momentum, it's unlikely that a lot of these people are going to use mobility services. They're probably a lot more likely just to continue status quo and buy a car. On the other hand, since we're right on the margin, if you push down if you push down mobility service prices not that much, you might actually begin shifting a lot of that curve over to the right. And that's the unknowns, right? But after running this simulation a lot, I don't even know what the final number was, we were always coming up with this number that was roughly 25 to 30% of the population would be economically better off using mobility services rather than owning a personal car, which can certainly be debated. So in terms of, and one of the ways that we try to address this factor in terms of debating whether or not that's true is that we create an interactive calculator online for people to use and test their own scenario. Because as I showed in that map, these things change a lot depending on where you are in the United States. So at rideordrive.org, you can go in and basically plug in your own scenario and see whether or not, given, say, the car price that you select, or how many miles you drive annually, and what the loan terms on your vehicle are, et cetera, you can figure out whether or not does it look economically rational to use mobility services. Let's quickly apply this same framework to carpooling because it's a critical piece of the equation in terms of whether or not mobility services will eat into the lunch of personal transportation in the future. So this is a figure from Uber, gives you a quick idea, right? As everybody might expect, the idea of Uber Pool is to try to get more people, more bodies in a single car in order to essentially reduce congestion and make our system more efficient. Of course, it's debatable about whether or not that will happen, but it's certainly an aspirational goal. And then more specifically, the idea is that if you achieve a certain critical mass of people that are riding in a similar direction, you could pick up multiple passengers along the way and then drop them off sequentially. So what we did to try to recognize some of this was develop a metric that we call density factor. It basically relates, or it's proportional to the number of passengers per mile. Some little bit of math on the left. You don't necessarily need to pay attention to it, but the point is, look at these two scenarios, and the top is you have 4 stops, A, B, C, and D. And those stops are separated by certain distances, 1 mile, and then 2 miles. And you could look at this in 2 different case studies. So in scenario 1, we have 2 riders, both picked up at point A, one dropped off at B, and the other dropped off at point D. And so the weighted average of number of passengers basically per trip length would be 1.25. In this other scenario, as you can see it, we have different passenger pickup, different passenger drop-offs, but we carry more people per trip essentially, and we end up with a density factor of 1.5. This is relevant because now we can start plotting additional heat maps to try to understand what is carpooling, or what's the potential for carpooling in terms of encouraging us to use mobility services. So density factor is actually increasing as you go down in this case, and years on the x-axis. What we're basically saying is that as density factor increases, we can have more and more, or mobility services becomes more and more appealing, right, as we all begin to split the fare between one another. And this is for the given conditions at the top in terms of miles driven, dollar per mile, et cetera. 2 quick examples in terms of the carpooling. If you have a really high dollar value per hour, it's just a total no-brainer. The challenge, though, is that if you have really high dollar value per hour, it's very unlikely you're going to be choosing to carpool. And we see that in the very nature of people, say, with conspicuous consumption, choosing to purchase very expensive vehicles, and which they may get a lot of utility out of. But my point in bringing that up is that the wealthy are arguably going to have different incentives than other people who are trying to maintain a tight budget. So there's challenges in terms of how you describe some of the economic behavior here. And then last, what I would show here is, what we're showing is the $14 per hour, again, coming from the Social Security Administration. And in this case, we see a lot of white, we see some red, and we see some blue. But I think the main takeaway here is that you have to achieve really high density factor before mobility services becomes of interest. What is that? It's exactly what it says up top. It's public transportation, right? So if you have the median wage in the United States, the way we achieve really affordable carpooling is with public transportation. You got to get really high density factors. Let's talk about automated vehicles pretty quick. I wrote this up in a presentation, I don't know, a number of years ago, and I think many people continue to, would probably agree with it, right, is that the shift to autonomous vehicles, it's going to be incredible. We don't have to necessarily talk about all those details right now because it's an endless rabbit hole. I would say it's second only probably to mobile phones in terms of the changing way that we, I would say, go about our daily lives and get our work done. The economics are compelling for replacing drivers with automated vehicles. If you are Uber or Lyft and you're able to purchase a fleet of automated vehicles, if you have the option of doing it. And if you're looking at a scenario where you're trying to figure out, is it worth it for you to replace drivers, imagine that you purchase vehicles in mass, like a large fleet of them at, say, $20,000 a piece, which is cheap. So I'm purposely doing that to try to make a pretty conservative case here. Driver salary at roughly $25,000 a year based on Bureau of Labor Statistics. Vehicle life, roughly 5 years. Just as a side note, average life of a New York City taxi is roughly 3.6 years. Discount rate of 10%, which is pretty generous, I would say. You end up with this present value of roughly $115,000. What does that mean? It means that if you could purchase an automated vehicle for less than $115,000, it would be worth your money. That's a lot, because existing guesstimates, if you will, which are all sort of wild guesstimates, but they're still become more valid as we get more and more data points, might be suggesting that we could eventually see automated vehicles at less than $50,000. In that world, Uber and Lyft will be purchasing automated vehicles hand over fist before continuing to pay drivers. There's also some interesting aspects here, which actually some of these are kind of related to the energy discussion we'll get to here in just a moment. Tesla Loop is the equivalent of a Uber or Lyft that was operating in Los Angeles, but they operated with nothing but Tesla vehicles or electric vehicles. In this scenario, they were seeing that this car, Model S, drove for 300,000 miles with maintenance costs on the order of $11,000. Remember, to put that in perspective, the conventional vehicle that we talked about was costing people roughly $10,000 every single year. People right now, I think, don't fully appreciate this fact, which is that operating an electric vehicle is almost an order of magnitude cheaper than conventional vehicles. And I think once that begins to sink in, it could really change the game if we culturally begin to better appreciate that. This aspect, this up here, then leads to this over here, which is that operating electric vehicles could drive the cost down to, say, 60 cents per mile. Remember those numbers I was showing was $1 per mile, and the whole screen almost turned blue. If you can get it down to 60 cents, the entire screen will basically be blue. We don't have to go into these details here, but the point is I was estimating what the cost reduction would be using automated vehicles versus conventional vehicles, with a kind of typical trip up top, a commission to the drivers, or a payment to the drivers as well as commission to the mobility service company like Uber or Lyft, and critically, an increase of roughly 10% in terms of the number of miles that are being driven as non-occupied periods. So when Uber or Lyft picks you up, then they have to drive around for a while. And Professor Carol Kockelman here at UT, they did some great work estimating that might be on the order of a 10% increase. It could potentially be even significantly higher than that. But let's at least use that as a starting number. You might get this trip down to like $9.20, roughly a 60% reduction in trip costs compared to pre-automation using a driver. So automated vehicles, they create this really uncertain future, though. I think there's a lot of people that say that shared autonomous electric vehicles are sort of inevitable and that they're going to carve up, in fact, some cases, I remember hearing Tony Seba and other consultants say that maybe we would need 80% fewer cars on the road. I would argue a lot against those claims. And one of the many reasons why I would argue that is that autonomous vehicles, they do what they continue to claim, which is that they have this potential to drive down the cost a lot. That's going to be really compelling for mobility services. But if you see the second bullet and all this here, is if you can get the price of autonomous vehicles down enough, it satisfies all of the things that you would want from mobility services. It recovers all of the time that you lost previously driving. You can now read a book in the back of your own car. That car will go park itself. The compelling reason why mobility services will push into the marketplace is because they're saving all of us time, whether or not that's what marketing efforts are really saying. That's really what they're doing for us. They're saving us time. They're making life more convenient. If our car does that on its own, I'm not actually quite sure why I would use mobility services. If I can afford to purchase that car on my own, it would just sit in my driveway, and maybe I would rebuild my garage. So, some of the energy implications real quick. This is a Sankey diagram. For those that aren't familiar with it, on the left-hand side, we have primary energy supply. On the right-hand side, we have energy services and energy rejected. In between is basically how energy moves throughout our economy and some of the critical sectors of the economy, and last, transportation there, that huge node that's consuming all of this petroleum and basically using 28% of all energy that we consume in the United States. So one of the big reasons why we built this economic model is because if we can basically estimate the economic value, we might begin to get a hint into how consumer behavior might change, and thus what those energy changes might be in the transportation space. A few case studies of that energy change. Case one is just the status quo. Case two is maintaining our existing fleet, but increasing those vehicle miles traveled by 10%. Case 3 is we replace 25% of light-duty vehicles with really efficient internal combustion engine cars. Why do I pick 25%? Because I'm trying to model what would happen if, say, mobility services, Uber or Lyft, actually did penetrate into 25 or 30% of the population, and they purposefully purchased highly efficient cars to improve their bottom line. And then the bottom here is 25%, but now in this case we're at electric vehicles. So those same case studies, you don't really need to pay attention to all the numbers in particular because there's a typo here. That bar should actually be a little bit higher. But case 1 is how much energy we're consuming in the transportation space. Blue is light-duty vehicles. The orangish color is other vehicles. At around 22 quads or so, equivalent of 22% of our energy consumption in the United States. Case 2 is when we increase our vehicle miles traveled. The bar goes up. It should go up a little bit higher than it shows there. Case 3, we've now introduced more efficient vehicles for fleets of mobility services. It begins to drop. And then we see, lastly, what happens if you have electric vehicles. Now, again, that's electric vehicles for only 25% of the fleet. And it also does not include the conversion efficiencies upstream for producing that electricity, which is a critical part of the question. But if you have to make then a decision as to whether or not, for instance, are you producing that electricity with a natural gas combined cycle plant, or are you producing that electricity from, say, a solar panel? And if you're producing it from a solar panel, efficiency is sort of a non-question. It's just whether or not are you producing enough electricity to charge your vehicle. So this is something that we just touched upon. If mobility services really take off, they're going to buy hybrids, highly efficient hybrids, or just pure electric vehicles because it's just so much cheaper to operate. And that could have the potential to create kind of a hockey stick in consumer adoption. In fact, we've already seen Lyft and others talking about purchasing electric vehicle fleets. And what is that going to do to these guys? How are they going to respond? Right? They're making their living off of selling oil and petroleum products into the transportation space primarily. Of course, some of it goes elsewhere, but it will be interesting to see how they respond. I would also bring up another interesting example is aviation. So roughly 20%, I think, of flights, if I have this number right, are essentially short-haul flights, less than 400 miles. Do you want to do this? Or would you rather sit in an automated vehicle that just drives you to Houston? Or maybe even that drives you to Denver overnight? Sounds pretty good to me in terms of being able to fall asleep in the back of a car. And so it's going to have this changes in our transportation behavior from how we move around our cities is going to have wide-ranging effects on GE, whether or not they're building enough jet engines, and Boeing and United and Rolls-Royce and all of them. And then another big question is what's going to happen to these guys. If they're buying fleets of electric vehicles, they're probably going to be buying them in mass. They're probably going to be buying them from large orders from individual companies. Are all of these companies going to survive, or is it sort of just going to be there's going to be fewer but larger automotive companies? You see GM in this kind of vein of thought invest $500 million in Lyft recently, or at least as of roughly 18 months ago, into self-driving cars. And that leads us to a question as I begin to wrap this up, that what could TNCs really be worth? If you start talking about the number of people in the world, the number of commutes, you eventually get down to this order where we're talking about trillions of dollars. And so if you have annual revenues of $1.5 trillion and you start talking about 1.5 times revenue, you pretty quickly get to this. And because it's potentially a high margin company, you're maybe arguably even much larger than that. And that gets to these discussions, which is all the money that's pouring into the mobility service industry. So different mobility service companies, and then the amount of money that poured into those companies over time. I think it's interesting to look at this because our model would help describe whether or not is it really worth it to be pouring this amount of money into these companies. And I would suggest that because it actually looks pretty economically compelling, if you can drive the cost down enough, that $50 billion going into this space is arguably pretty justified. Now, granted, it'll be interesting to see how it plays out because all these companies right now are essentially losing money in the effort to just grab up market share. But what's going to happen 10 years from now after a few of them survive will be interesting to see how that plays out. So some closing thoughts. Shared autonomous electric vehicles are not the only solution that I want to reinforce. this discussion was binary, but we have to consider public transportation, we have to consider cycling, we have to consider walking and just improving our cities in general to try to figure out how are we going to improve our transportation in dense urban centers. Average ownership, as I acknowledged, is roughly 7 years. It will take time to convert the fleet. So people that are claiming that this is going to be happen overnight, I don't think are accurately recognizing how long it takes to convert an automotive fleet. Cars are status symbols. I think people will continue to purchase cars for a long, long time. Millennials are definitely changing their consumer behavior. In fact, many of them don't even want a driver's license. So few of them are purchasing cars. I think it will be interesting to watch what happens as they get married and have kids and potentially search for affordable housing that might be on the exteriors of cities. And so if that happens, they might very well go back to purchasing cars. Mobility services are currently making the situation worse in a variety of ways. So that extra driving that they're doing between customers is actually causing real traffic in places like Manhattan. Now, Manhattan's not a perfect example for the rest of the country, but they are causing problems in addition because they're subsidizing prices, public transportation ridership has plummeted. Why would you ride on a bus when I can order a personal car? Literally, that's what I do. I order a personal car that costs me $3 to get from my house, basically $4 to get from my house to work. Why would I ever take public transportation? Now, granted, I actually do take public transportation almost every single day, but my point is, when it gets late, I do take an Uber home because it's really cheap. And so I think we have interesting questions as to how do we maintain our public transportation system while also encouraging mobility services, because if we can carpool, it could be really, really valuable to the community in terms of reducing congestion. Now, it provides a lot of other value on its own in terms of our individual point-to-point ridership, and it might be more than economic compelling for us to use it as individuals, but I think it's worth considering what the broader impacts are. They will almost certainly accelerate EV adoption, and autonomy will almost certainly increase vehicle miles traveled, unless we carpool. That's a critical thing. And then last is, what's the value of your time? Think about it, because that's what is actually driving a lot of these decisions, whether or not you realize it or not. Mobility services are providing a service that allow us to live our lives more efficiently rather than walking back and forth, say, from a parking garage. So with that, I will stop. Actually, I should acknowledge Oak Ridge, Gordon Sy, who's sitting in the audience, and some of my colleagues, Michael Weber and others, Matt Mangum, help with a lot of this work. So let me stop there.
Thank you, Todd. That was interesting. I'll take the advantage of the first question since I have the microphone here. I live in suburbia, obviously. My wife is a stay-at-home mom, works at the house. Something we've seen a lot in the last few years in our area is Walmart, Target, H-E-B rolling out these delivery services to where, back to the how do we value our time question, apparently we're either extremely lazy or we value our time very highly, not even just in the standard commute environment, if these delivery services seem to be rapidly expanding to where we don't even want to drive to the grocery store or the Target or the H-E-B. How would some of these autonomous vehicles or stuff actually take a lot of those cars off the road if we got autonomous vehicles running back and forth for a lot of these delivery services that are currently fulfilled by personal passenger vehicles? It's
a great question, because it's exactly related to this in terms of all of those services have a compelling economic case because they're saving us time. And even you look at Amazon, right, or other delivery services where I don't like going to a lot of stores. I don't like, now there are scenarios where instead of going to a store and trying multiple things on, you might just order 5 things and then ship them back. And it's totally changing the way we consume products in the United States and throughout the world. And it's the same with groceries. There's a big gradient there as to how that service gets delivered. In some cases, like the H-E-B near our house, it's real close. So we place an order, and sometimes we just go pull into the parking lot and they walk it out to us. But I think it costs something like $5 for them to do that. But me walking around the grocery store for what could be 40 minutes, I don't like, my wife loves walking around the grocery store and planning what we're gonna eat and stuff. I do not like walking around a grocery store. I'm in, like, grab the milk, let's get out of here. And so in those scenarios, you're saving a customer a lot of time, and it's the exact same compelling scenario. It will be interesting to see how it plays out in terms of energy consumption and the number of cars on the road, whether it's increasing it or decreasing it. If all of us are driving our individual cars to the grocery store, then that's arguably more cars on the road than if there was just one big truck kind of going around and delivering it. It's a little less clear in terms of what the overall energy consumption is, though, because we actually have another similar study going on that's looking at the energy trade-off of buying from grocery stores or purchasing, say, like Blue Apron, which bring food directly to your door, right? And you know, a recipe in the whole 9 yards. What it really comes down to is the packaging in terms of what the overall energy consumption is between those two cases. So if you have a lot of packaging that gets delivered to your door as Blue Apron, then that dwarfs actually the transportation costs. And so you're almost better off everybody individually driving to the grocery store. So there's some interesting stuff going on as to how they make their packaging more environmentally friendly, and I think the same case could be made for Amazon and all of those services. So economically, it's really appealing. It's unclear what the energetic and emissions impacts are.
Thank you. I think that was a really wonderful talk, a wonderful analysis. And what I would add to your analysis, what I think might be missing a little bit is the other business model of the car-to-go or Zipcar, where you can rent a car on demand just based on when you want to use one and drive it yourself. And I think that might become a more important model, or can be a very important model within, you know, electric cars being available in that way, especially in an urban environment. So I wondered if you could comment on that other business model that wasn't in your...
Totally agreed. And it's sort of like arrows in a quiver, right? That it should be there as a tool. And it will absolutely provide the service needed for certain customers. I actually know and have friends who had 2 cars, and they sold one of them and then started using car-to-go whenever they periodically needed a second car, which was rare. And so you could almost make the same case for mobility services. It's sort of just like dependent upon what's your usage profile and what's the density of adoption in your area in terms of the number of cars that are available, or even by analogy, the number of Ubers or Lyft driving around. Almost all of these products require that you kind of hit a critical mass before they become really appealing. And so it will be interesting to see how the consumer sort of plays out. Another interesting thing actually is like dockless bike sharing that's happening in a lot of dense urban environments now, where sort of similar to a car-to-go, there's now, you know, people might just have what used to be a city bike that was actually docked, you know, in Manhattan. They're able to just sort of take them wherever they want. It's causing some problems because people are just leaving them, you know, randomly on the sidewalk, which is annoying. But on the other hand, it creates new modes of transportation that arguably have really low barriers to entry, which might be really appealing to certain customers. And then how that plays out in terms of, and I say barriers of entry in terms of cost. And so and how that plays out for certain customers will be interesting, because as we have more and more available options, it might mean less and less congestion if we do it wisely. So car-to-go certainly should be part of the conversation. I just failed to mention it.
Thank you, Doctor. That was a very fascinating talk, but at the risk of sounding like a Luddite here, I mean, we're talking about Uber and Lyft, and I mean, the way you suggested the model was going to change, which is them acquiring assets as cars and automating the entire process, is sort of a radical change to how they work right now. And the idea is, I mean, if you just look at the physical assets of these two companies, maybe they're a building with a couple of computers in them. They don't really own anything down there. So, I mean, when I saw how, when you were adding the numbers, when you got that 114,700, there was the price of the car. But I mean, if you see it that way, I mean, they're not really paying for the car. They're paying for the driver, which was very similar. You put $20,000 for the car and $25,000 for the driver.
Yep.
So, I mean, that is one of my questions here. And the other thing is, I mean, you'd be phasing out a lot of work for people that are really enjoying it. Now, this was the part where I could sound like a Luddite here, but I just want to see your take on it, at least. And because, I mean, automation definitely is something that's going to grow. Even if we heard of that accident a week ago and it was in Arizona, I think.
Phoenix, yep.
Yeah, I mean, that's not really going to stop that train, but there's always going to be this relation, you know, like how romantically petrol heads speak about cars and stuff. I mean, you just said, for example, you go to Denver by just sleeping in the back of the car, but some people really do enjoy the process of doing that. So how do all these like issues fit into like the model of automation? Thank you.
Well, so let me try to address maybe some of the things at the end. I personally really enjoy driving, actually. My wife and I often choose to drive on long trips just because I enjoy seeing the countryside. And so the thing that I offer up in terms of that conversation often is that I don't have to actually own a car to do that. I can still rent a car, right? So I may own no cars at some point in my life, but when I want to drive somewhere, I can rent one. Or if I want, as a petrohead, you know, go drive the hill country on the weekend, and I can rent a really nice car and a really fun car and go drive for the weekend. It will be interesting to see how that changes as generations shift, because there were pastimes, and I say pastimes as in like hobbies, that people held 100 years ago that I don't think we necessarily hold the same hobbies today. And so how that changes over time, it's unclear, but I don't think it's set in stone that people inevitably will always want to drive themselves, even though I personally enjoy driving myself. In terms of the pricing of cars, it is unclear how an Uber or a Lyft might sort of acquire a fleet. They could, in the most simple way, just purchase a fleet of vehicles. It might also be that Google, or say Toyota, owns the fleet, and that Uber is almost just operating on top of them as a platform, similar just like any software platforms, right? That people build on top of each other and still deliver a compelling product to the marketplace. So I don't know whether or not Uber will actually end up owning the vehicle, but say Toyota does. Well, then Toyota's not paying $20,000. You know, they built the thing at the cost of materials for whatever it might be, $15,000, and then they're marketing it up to Uber so that they make a profit, but still at the end of the day, it might only be $22,000 to Uber to use that service. So I think it still ends up as a really compelling number that automated vehicles, the value add that they're providing in terms of no longer needing a driver is a lot of money. What that means from a societal standpoint, I almost wouldn't even want to venture to guess. That it's unclear in terms of drivers with that and what the societal impact will be. With that said, some of the major semi manufacturers and truck manufacturers are actually seeing a pretty interesting world where autonomy with fleets of trucks, you might have a really highly paid individual who's managing that say like 3 autonomous trucks that are going down the road. So instead of maybe 3 truck drivers, maybe you have 1, and now he or she is receiving a higher wage. How that then plays out for the rest of the marketplace, unclear. If it drives down cost of goods, then actually other people might have the same quality of life for a lower cost. So it's really complicated in terms of what the job impact is. I am relatively optimistic in terms of what the impact will be, but you know, we'll kind of see. Let the marketplace decide, I guess, is maybe my opinion.
Hey, Todd. Thank you for that. So this might be a little granular and you may not be able to speak to it, but what about, say, workers who are reimbursed on a per diem basis or per mile basis for traveling to work? And I'm wondering if that's really a policy change that needs to happen to discourage people from driving to work and actually profiting from driving to work in some cases.
Yeah, that policy has an amazing way of distorting the marketplace in some good ways and bad ways. And so in that case, I mean, a similar way plays out with parking and tax incentives. So like, just as another example, building off of your comment, many companies that work and have offices in the most expensive real estate in the world, say like Manhattan, get tax cuts or tax incentives to write off basically their cost of parking to subsidize their employees to drive to work. So it's completely skewing what the apparent price of parking is and changing our behavior similar in a way as that. If you reimburse people for driving, inevitably they're going to do it because they're getting paid dollars to drive to work, which they have to arguably do anyways. So how that plays out in the future is unclear, but I do think we need to be open-eyed going into these situations and recognize how we're arguably distorting the marketplace almost for the worse. Sometimes in the name of societal good, and often it might not be. There's a lot of policies that do result in societal good, but there's many that have damages, such as the one you suggest. So I don't know, unclear. Yes. That's a challenging one because it's really location dependent. On a per person mile traveled, public transportation delivers exceptional results until you get to the point that it's so complicated and old and convoluted that you're spending billions of dollars per mile, like what just happened in Manhattan. So it's unclear long term how that's going to play out. I would say that in general, places that have really good public transportation are often spending less per person. If you really accumulate all of the costs, all in costs, so maintenance of and construction of really large highways. But it's really case dependent. There's no real answer to that to pin it down. And I don't know the specific numbers for San Francisco versus, say, Austin. It's unclear. You know, the construction of the train that we considered in Austin a few years back had a shockingly high sticker price, and a lot of people rejected it for that reason. What I think was lost in the conversation was the price to expand I-35 through downtown Austin. If that price comparison had been made, I think you get to a more compelling story as to it costs a lot to do stuff nowadays. It's just the answer. You've got to make a comparison to make people realize how much this stuff costs. Because it was orders of magnitude more money to expand I-35. Now, granted, with that said, if I remember the numbers right, not orders, but factors more to expand 35. Granted, of course, it's not totally apples to apples. You might get more people traveling on I-35 versus a single train, whether or not people adopt trains. It's a complicated story, but it's worth comparing ourselves to other cities to see what we can do better.
Let's take one more question.
Oh, you want me to ask? Okay, yeah. Do I, okay, it's good. So I love how you start out by acknowledging the reality of that everyone drives cars, and we have to start with that point. But then a lot of the rest of the talk is in a hypothetical realm of the future where people are driving driverless cars, or there's electric vehicles, neither of which exist yet. As you said, they're years and years ahead of us. What we have right now is TNC that's using real drivers as an option, and it looks like from the talk as if your conclusion is that 30% or so of people maybe should be driving them, but most people shouldn't. So another question I have is, what about these other models like Ride Austin, for example, a nonprofit model? So is it possible that public transportation, you talked about how there's lots of public transportation reasons people don't want to get on buses or whatever, the inconvenience of it, waiting for it, don't want to be with a whole lot of people in one place. So is it possible that we could have a shift? Have you considered the possibility of shifting a major city shifting to a TNC style public transportation system, which is kind of happening inevitably right now. It's happening in Austin right now. People are riding the buses less. So what if what if the city of Austin or major cities were to follow the example of UT right now, where they're partially doing this by late at night offering free Lyft rides at times when the buses are being less used to the distant places that students live. What if they were just to commit to a full program, where the city of Austin paid drivers right now, next year, the year after, to start driving people around instead of going on buses? Is it possible that that would change your equation? Have you considered that?
Well, I mean, the moment the city or the government in general gets involved with the pricing of the product, it gets complicated. Because it's almost the exact same situation as private equity and venture capitalists right now essentially subsidizing the price and making it even more appealing for us to use mobility services. Arguably the exact same thing happens if the city or the government begins to subsidize the price or provides a tax break or whatever it might be. Then the costs to the consumer aren't as apparent. They're not transparent. And that distorts behavior. Whether or not it distorts behavior in a good way, I don't know. And so would it be better if the city was doing that, or as you know, maybe like UT doing it late at night in part for safety reasons? It could provide benefits, but I don't know what they would be. It's hard to venture a guess. You're right that we sort of start in what is currently happening in the real world and then where we're potentially going. But I think we do that to try to recognize, is this going to be economically compelling? I think it will be for a certain portion of the population. And then if the cost can be driven down, whether or not that's just by pure technical innovation or if it's by policy, as you sort of suggest, then it changes the equation a lot. It doesn't need to change the dollar per mile a whole lot before it's really appealing to a lot of people. So I hope that answers your question, roughly.
Yeah, it does in some ways. And I guess I should say the reason why I'm thinking about this is partly that we have a lesson from roughly 100 years ago when, like, the city of New York allowed private companies to dig up the streets and build private subway lines in competition with each other. And in the end, the lesson that was learned was that that's not a very profitable business, and that that in the end, the city took over those systems and made them public, and now that's how people get around in New York. So I'm wondering, here we have these companies that they aren't really profitable, like you're saying. They're not really companies. They're kind of fake companies being propped up by venture capital, and maybe we're going to get to a point, regardless of all these changes in technology, we might get to a point where we decide that's not the way, that doesn't make any sense to operate businesses like that. And maybe all this is going to be public in the end anyway, right? That's a possibility 10 years from now.
Well, I guess I would push back a little bit just because the cost of public transportation is also really hidden. It's really non-transparent. People push back on, say, toll roads a lot. But the beauty of toll roads is that it's very apparent what the cost is. And that makes it very clear how people make their decisions to, say, move around a city. When, say, the city of Manhattan pulls back, privately owned subways, I think it's a little more complex than that because similar to utilities like a gas line or a water line going to a house, it's a situation where competition is hard to replicate at a grand scale. In this scenario where you have mobility services, I actually think a competitive marketplace can work well. And in that scenario, I'd much rather give it to the private sector and let them figure it out. If we're going to burn through a bunch of private equity guys' money and venture capitalists in the meantime, I'm more okay with that than burning through taxpayer money. That it's just less clear what the incentives are for the people playing the game. And so if Lyft and Ride Austin and Uber all compete, even though they have different business models, as you said, like Ride Austin's a nonprofit, I think that's going to arguably, in this case, get us to a better solution. Whereas with subways and utility lines to houses, I do think that the public clearly needs to be involved in that conversation because it's just harder to develop a competitive marketplace for that.
All right. Well, thank you very much, Todd. Very good talk.
Thank you.